Hello, everyone. Today we're going to work on trig. We're going to continue our work with the right triangle trig units that we've been working with, but we're going to really look at graphing these and what these look like graphing over this rest of this week. And then next week we'll really look at applying these, and then we'll have our assessment on this. So let me go ahead and present and share it with you guys. So we are going to look at exploring periodic data today. Okay. Identifying cycles and periods of a function. A periodic function is a function that repeats a pattern of y values or outputs at regular intervals. It doesn't have to be symmetrical, but it's just going to repeat those in a regular interval. One complete pattern is a cycle. A cycle may begin at any point on the graph of a function. The period of a function is the horizontal length of one cycle. Periodic behavior is behavior that repeats over intervals of equal length. So one cycle can't be longer than another cycle. Oh, the dogs are about to go crazy. This is going to be fun. So example 1, let's analyze this periodic function below and identify the cycle in two different ways. Okay, what is the period of this function? So here is the cycle right here, and it's always from one point to the other. So we're going to say from right here to right here, which is the maximum to the maximum. We're going to max to max. That's one cycle, or it's one cycle. Now the period is that length from there to there. And from here, this is 2 to 6, so the period would equal 4. Another one you could do is from here, where it touches the x-axis, to here, where it touches the x-axis again. Now, it does touch in between right here, the x-axis, but that in between right there is where it's decreasing. Both of these are where it's increasing, and it would complete a whole cycle. And again, the period from here to here is from 8 to 12, or 4 units. Okay? So let's look at A and B. If I go from the maximum to the maximum, which is right here to right here, we go from -3 to 1. So the period would be 4. Likewise, and I'll hopefully get to do this in black, if we were to go from here, where it's decreasing, right at that point, to the next point where it crosses the x-axis and is decreasing that point, and we follow that along, that's a whole cycle. It would also be 2 from it'd be from -2 to 2, which is 4 units. The distance is 4 units. Let's look at B. B, if we go from maximum to maximum, from here to here, we go from -3 to 0. So our period is 3 units. You could also choose to go from minimum to minimum. We haven't done that one yet. And from minimum to minimum, it's from 2 to 5, which is also 3 units. The distance is 3 units. Okay. Now, to determine if a function is periodic, analyze the function graph to see if the y values or outputs of the graph repeat. Do the y values repeat? Is the function periodic? If it is, what is its period? So looking at A, is this periodic? No, because the y values don't repeat. This y right here is at like 3.5. This y right here is at like 2.5. Even though it is going in a pattern, the y values don't repeat. It has to go horizontally across. Since this is going diagonally down, it's not periodic. Let's look at this one. Now this has a little weird bump, but all of the y values repeat. So if we were to go from here, this point, to where it repeats again at this point, and we made a full cycle through, say hi to Spud real quick, we would go from -2, sorry, these are counting by 2, so from -2, 0, 2, 4, 6, 8. So from -2 to 8, which means it has a period of 10. Likewise, you could look from the maximum to the maximum, and this is at 0, this is at 10, so it has a period of 10. It is periodic. Now, I want you guys to try the next one. I'll pause the video real quick and you try. So this one right here is not periodic because it is on a diagonal. This one right here is periodic, and if we go from the maximum to the maximum, -2 to 2, the period is 4. Okay. So the midline. The line where y equals, it's going to be y equals something, that cuts the function in half horizontally. Amplitude. The amplitude of a periodic function measures the amount of variation from the midline in the function values. The amplitude can be found by finding the difference between the maximum, if I can spell it right, between the maximum and minimum and dividing by 2. So midline is we'll go over this. Amplitude first. Amplitude of a periodic function is max minus min divided by 2 because it's the difference. Now the midline is where you add them because you're trying to find like the midpoint and divide by 2. If you remember finding midpoint back in Math 1, you added the two x values and divided by 2. Same thing here. So midline, you add and divide by 2. Amplitude, you subtract and divide by 2. Amplitude is the difference from wherever that midline is to the uppermost point and the bottommost point, and trying to find how big that difference is. Now, it measures the amount of variation from the midline. Just want to make sure we're clear on that. Variation from the midline. Okay. So right here we have a maximum value at 4, a minimum value at -2, and 4 minus -2 divided by 2 is 6 divided by 2, or 3. So that's your amplitude. And then your midline would be 4 plus -2 divided by 2, or 2 divided by 2, which is 1. So we would have a midline. I'm going to do this in a blue color, so hopefully it stands out. We would have a midline right here, and each line is worth 2 here, so we have to be a little bit careful. We would have a midline at y equals 1 here. And that's if I were to fold this graph in half, the max and min line would be on top of each other. Not that the values would be on top of each other, but the max and minimum lines would be on top of each other. Okay. So what is the amplitude and midline of the periodic functions below? So let's see. The maximum here is 4, and the minimum here is -4. So if we add those and divide by 2, so 4 plus -4 divided by 2, that's 0 divided by 2, or 0. That gives you your midline, which is at 0. That's your midline. And then if you subtract them, 4 minus -4 divided by 2, you get 8 divided by 2, which is 4. And that is your amplitude. Okay? Likewise, the maximum here is 2. The maximum or the minimum is 0. So we add them, divide by 2 to get the midline. 2 plus 0 is 2 divided by 2. The midline's at 1. And you can draw that in if you want to. And A, if we subtract them, 2 minus 0 is 2 divided by 2, 1. The amplitude would also be 1. All right, if you guys want to try these yourself, I highly suggest it. Pause the video, but if you're not there yet, that is fine. The maximum here is 1. The minimum is -2. If we add them, we get -1 divided by 2. So midline is -1/2. And then A, if we subtract them, 1 minus -2 is 3 divided by 2. And that is your amplitude. Okay. Over here, our maximum here is 3. Gotta see what your lines are worth. And our minimum is 0. If we add them, divide by 2, our midline is 3/2. Sorry, that bug's in the way. And if we subtract them, 3 minus 0, our amplitude is also 3 divided by 2. So that is what you should have. Okay. So, a couple more things, and then you guys get to practice this on your own as we keep going. So, the sine function is y equals a sine b theta, and the cosine function is y equals a cosine b theta. The big thing I want you to show you here. The sine function starts halfway through an increasing. If you guys can look, it's halfway through its increasing section. That's where it is on the y-axis. So halfway through increasing. If you find it halfway through decreasing, then something has happened and maybe it's been reflected. Over here, the cosine function starts at a maximum. So those are the big differences between the two. The cosine function is going to start at a maximum. All right. Now, couple of key ideas. The absolute value of A is the amplitude of the function. So see that number in front? That's the amplitude of the function. B is the number of cycles in the interval from 0 to 2 pi, which means B is equal to 2 pi divided by the period, or the period, this is what's going to really help us, is equal to 2 pi divided by B. So we're able to find the period by using B. So let's see if we can find, and the cats are all in the way, we can do this together. So find the period of the sine curve, then write an equation for the function. So the period, if we start here, and we go back around to where it's increasing again, right here, it goes from 0 to pi to 2 pi. So if you see pi is halfway through, so this is a full 2 pi. Now the amplitude, the maximum is 2, the minimum is -2. We add them together, 2 plus -2 divided by 2. Sorry, we subtract them. Amplitude you subtract. 2 minus -2. 4 divided by 2 equals 2. So the absolute value of A is the amplitude. And since this is increasing, this is a positive 2. B is equal to 2 pi divided by the period. 2 pi divided by 2 pi is 1. Because the period is 1. Or sorry, it's 2 pi. So 2 pi divided by 2 pi is 1. So the equation, and they said it's a sine curve, is y equals a sine b theta. So now we're going to fill this in. Y equals 2 sine. Now we could put a 1 in front, but it's kind of pointless, so we just say theta. Because the 1 in there is implied. All right, so now you try this yourself. Pause the video, you try. Okay, again, we have a sine. It's increasing. Starts here, increasing again right here. 1, 2, 3, 4, 5, 6. So if this is 2 pi, this is pi. So the period is pi. The amplitude, this goes up to 2.5 and down to -2.5. So 2.5 minus -2.5 divided by 2 equals 5 divided by 2, or 2.5. Now, I know this seems kind of silly because it goes up to 2.5, but sometimes these are going to be translated, so that's why we do it like this, just to show you where we're getting our numbers. So A is 2.5. Remember, B is 2 pi divided by the period, which is pi. They cancel out, so B equals 2. We fill this in. Y equals, we're using this sine one again, so A, 2.5 sine B 2 theta. And there you go. Sometimes instead of theta, you'll see X there, just so you guys know. All right, last one. Find the period of the cosine curve. So this time it's cosine. Then write an equation for the function. So first of all, let's try the period. So here's a minimum. Here's a minimum. It goes to pi. the amplitude. Now the amplitude, the highest it goes is 3. The lowest it goes is -3. So 3 minus -3 over 2. 6 divided by 2 is 3. Now this is where it's a little bit different. A, because I told you that cosine start at a maximum, but this one's starting at a minimum, that means A is negative because it's been reflected. Remember, when we put a negative in front of a function like this, it means it reflects across the x-axis. And then B, we do 2 pi divided by pi, cancel, equals 2. So as we fill this out, this time we're doing cosine. Y equals -3 cosine 2 theta. And again, sometimes you're going to see that as an x instead. Now, what we can do here is we can put this into Desmos. If I have Desmos up here, just regular Desmos. I'm looking at some activities for you guys to do on Desmos. So we can put this into Desmos. And as you can hear, the dogs are going crazy. Y equals -3 cosine 2. And now here I can put in x, or I can put in theta. And to put in theta, open up your keyboard, go to ABC, and theta is right under the P. But x works just as well. And you should see your answer right here. So the full period from here to here should be pi. Let me close this to see if it's pi. So this is 0, -3. This is pi -3. So it is pi. We did well. And the highest it goes is 3. The lowest it goes is -3. So you did it correctly. Your classwork today is going to be, well, your homework 5.5. You are going to share that with me, and then we should be all good to go. I hope you have a great day.